Show that that is equal to that. I'd rewrite that in sine and causes. So I'd say, I'm going to split it up for you. I'm going to say 1 over cos squared divided by um, sine squared over cos squared. Okay. Our reason did that is just because you'd have four fractions onto each other. It's not really nice. So we don't divide fractions, we flip them and times them. So we've got 1 over cos squared times cos squared over sine squared. Cos's go away. That leaves us 1 on sine squared. And 1 on sine squared is equal to cosec. And that's my dog. Hey, bear. Good boy. Next one, the function, this 2 minus 2 to the x is dilated vertically by a factor of 2 and shifted 4 to the right. Find the equation formed and sketch the result. So when you got something with a vertical dilated, it's like multiplying everything by 2. So what we're going to say here is f of x is equal to 4 minus, I'm going to say 2 times 2 to the x. And the reason I want to do that is I'm going to show you in a second, is for a very particular reason. Okay, then we got 4 units shift to the right. Now we're shifting something to the right by 4 units, you're really just affecting the x part. So we can say 4 minus 2 times x. I'm going to say minus 4 there. So shifting right. Now the whole reason I did the first step was for this very part, this part here. Oh, you want me to throw your toy? Ready? Go on. Go get it. Okay. The whole reason to do it for this part right there. Because what we can say is we can use our index laws and say 2 is the same as 2 to the 1. Now, times becomes plus. So what that actually really changes this to is 4 minus 2 to the power of x minus 4 plus 1, which is, we should write f of x. F of x is equal to 4 minus 2x to the minus 3. Okay, so simple concept in terms of the translation, but very different to something you've probably seen before. Okay, so some key features we have to show. We've got a sketch here, so we want to know our x and y intercepts. So to find the y-intercept, we set x equal to 0. So we can say y-int equals 4 minus 2 lots of 0 minus 3. Okay, so put that in your calculator and you get something just below 4. It's like 3 and a bit. 4 minus 2 to the power of minus 3. 3.857. So something about there. And if you really want to, you could write 3.8. Say 57 or 75? 75. Okay. That's our x, y-intercept. You also should know there's an asymptote, and I've probably drawn that too high. Probably really want to move that down if I could. Okay, there should be an asymptote at 4. Why? Because this thing can't go above 4. So what you want to see is something like this. Not touching, oops. not touching 4. And you've got to figure out the x-intercept. Oh, I'm going to show you what it was. So something like that. It's a bit of a curve. It's not my greatest drawing. 3.875. So put that underneath 3.875. And this one would be 50. How do you get the x-intercept? This is one's a little bit of trickery. X-int, x-int, set y equal to 0, or f of x. So we're going to say 0 is equal to 4 minus 2 lots of x to the minus 3. For me, I'd move the minus 2 over. So 2 to the x minus 3 is equal to 4. For me, I see this as a base answer power, so the log. So I would rewrite this. So don't forget when you see, base. So when I think about log, let's write over here. If I said, log of a b equals c, what we're talking about there is that's base answer power. So base answer power. Okay, and we've got something a similar situation here. So what we can say here is log base 2 to the 4 is equal to x minus 3. Another way you could do this is think about the powers. 2 to the power of what gives you 4? It's 2 to the power of 2. So what can you do to make this part up here a 2, make it a 5? You can do that. That's how I did it. Doing this, put that in your calculator, and I believe that is equal to 2. And that's 2 minus 3. Add 3, and you get x is equal to 5. Okay, you guys can do that in your calculators, so go for it. So there's that one. Particle moves in a straight line. Its distance x meters from fixed point O, the given line by that. Sketch the graph. Now, a couple of things you've got to realize here. What is this 3 doing? 3 is changing the frequency. So what that means is everything's going to happen 3 times as quick. And the 2 is changing the vertical dilation. Okay, so this time what we've got is this: we go from 2 to negative 2. Now this part of 3t just means we have to do 3 sine waves. So we're going to go 1, 2. Oh, that last. Oh, really? 1, 2, 3. And 1, 2, and that's going to come back up. Okay. That now there is actually 2 pi. Okay. So everything that has happened before is happening 3 times as quick. So normally this would be, if you think about the normal one, like this, that's pi on 2, pi, 3 pi on 2, and 2 pi. Now what I'm going to do is just divide each one of these by 3. So this actually becomes pi on 6. So these all go up in pi's and 6's now. So this would be 2 pi on 6, 3 pi on 6, 4 pi on 6, 5 pi on 6, 6 pi on 6, 7 pi on 6, 8 pi on 6, 9 pi on 6, 10 pi on 6, 11 pi on 6. The last one would be 12 pi on 6. So now I've got it between 0 and 2 pi, and it has a frequency of that. So we've got that. Then the question says, find when its particles first at rest. Now, when it's first in rest is, got to remember what this is actually talking about. It's not that it's when is it first back down at 0. Okay, at rest means we're at a stationary point. So, that's what we're looking for. We're looking for a stationary point. When's the first time it hits stationary point? It's pi on 6. So T is equal to pi on 6. That's when it's first at rest, when it's not moving, not changing distance. Because it's just, hey, stopped. All right, next one. What time we got? 2 minutes. Yeah, why not? Show the value of K is 4. The queuing time, X minutes of teacher waiting on the phone with the Department of Education. It's probability density function of that. So what we're going to do is we're going to integrate. And we want to show that this is, again, from 0 to K, because we don't know what K is. So talking a probability density function, we put in the value K, we put in 0, we put in the function, 3 on 32, X outside of K minus X. For me, I'd bring up the 3 on 32. And we've still got this from K 0, X, K minus X. And don't forget that is dx, and that is equal to 1. Oops. Yeah, we've still got time. Okay. So what we can say from there, for me, to make this a little easier, and don't forget, this is dx, and this is equal to 1 too. Equal to 1. And what I might do, just to make my life easier, I'm going to get rid of this 3 on 32 the other side. So I'm going to say 3 over 30. Oh, I'm not. I said come on the other side. I'm going to expand this a little bit out here. Just don't have to use any chain rules or anything. So I'm going to say k to 0, xk minus x squared dx is equal to 3 over 32. We can integrate that. So that becomes x squared k on 2 minus x cubed on 3, and that's between k and 0 is equal to 3 on 32. All right, so we can substitute in k's, and when we do that,